Hi everyone. In this video we are going to learn about trigonometric ratios of complementary angles. In a previous video we have discussed about trigonometric ratios of a regular acute angle. Here we are going to see what would be the trigonometric ratios when we talk about the complementary angle of the acute angle. For example, in this picture you can see we have a right triangle and the triangle is ABC, and this is the right angle. The angle C is the right angle. And the three sides are A, lowercase a, B and C. So for this picture, if the angle B is theta, then sine theta would be B divided by C. That's the ratio for sine theta. And cos theta would be A divided by C. Similarly, tan theta would be B divided by A. And cosec theta would be reciprocal of sine theta, which will be C by B. And then sec theta would be C by A. And cot theta would be A by B. Right? Now, if we talk about what would be the trigonometric ratios for this other angle, which is angle A, and if you think about it, this angle A is nothing but 90 degree minus theta, because the total angle in a triangle is 180 degree. One of them is the right angle, which is 90 degree. So you are left with another 90 degree between theta and the other angle. So the other angle would definitely be 90 degree minus theta. So now we are going to see what would be the trigonometric ratios for 90 degree minus theta for the angle A. So let me draw a new triangle which will look similar, and then we'll discuss about the trigonometric ratios. So in the second triangle, as you can see, if theta is the angle B, if angle B is theta, then angle A would be 90 degree minus theta. And now we are going to try and find out the trigonometric ratios for the angle A, which is 90 degree minus theta. So what would be the sine of that angle? Let's find out. So sine of 90 degree minus theta would be the opposite side divided by hypotenuse. Now in this case, if you carefully look at the second triangle, you will see that for angle A, which is 90 degree minus theta, for that angle, the opposite side is actually BC. That is one thing you have to carefully notice, that angle A is actually looking towards the side BC. So that is the opposite side of that angle. And now we are talking about that angle, which is a complementary angle of the angle theta. So angle A being the complementary of angle theta, you can see that his opposite side is actually the side BC, whose length is A unit, lowercase a unit, right? So that's his opposite side. And what is the adjacent side? Well, his adjacent side would be the side AC, because that is what is next to the angle. It's actually one of the sides of the angle. Whether it's the initial or terminal doesn't matter, but it's one of the sides for that angle. So that is the adjacent side. But the hypotenuse remains the same, because hypotenuse is always the side which is opposite to the right angle. And here our right angle is the angle C. So let me quickly indicate that. So our right angle is angle C. So hypotenuse is always the opposite side of the right angle. So no change in the position of hypotenuse. But in this picture, if you notice that the opposite side now is the side which used to be the adjacent side in our previous picture. Because in the previous picture, if you think about it, the adjacent side was the side BC. But now in this picture, side BC is not the adjacent side. It is the opposite side. Why? Because we are talking about angle A. We are not talking about angle B, which is the theta. We are talking about the angle A, which is 90 degree minus theta. So for that angle, you need to clearly understand that his opposite side is the side BC and his adjacent side would be the side AC. Now, if that portion is clear, then rest of it is very easy. So now your sine 90 degree minus theta would be equal to opposite side divided by hypotenuse. So in this case, what is the opposite side? Well, that is A. And what is the hypotenuse? Hypotenuse is C. So it would be A divided by C. And now, if you look at our previous note, which is the trigonometric ratios for the acute angle theta, now from that note, you can see that A divided by C is actually cos theta. Let me highlight this right here. A divided by C is actually cos theta. So now what we are seeing here in this picture, that sine of 90 degree minus theta is equal to A divided by C, which actually corresponds to cos theta. This is the interesting thing. You have to understand that the trigonometric ratio of a complementary angle is actually the co-ratio of that angle, meaning if it is sine, then it would be cosine, which is cos, right? So if it is sine 90 degree minus theta, its value is actually same as cos theta. I hope it is clear up to this point. Let's move on to the cosine of 90 degree minus theta. Let's see what that evaluates to. So cosine of 90 degree minus theta would be equal to adjacent side divided by hypotenuse. So in our new picture in the second triangle where we are talking about 90 degree minus theta as our main angle there. So the adjacent side is B. So it would be B divided by C. That's the ratio. Now if you look at our previous note for the regular trigonometric ratios of the angle theta, their B divided by C is actually sine theta. It's right here. Let me highlight right here. So this is actually sine theta. So here we can say, okay, this is then same as sine theta, and that is correct because cosine of 90 degree minus theta is actually same as sine theta. Now in this picture, in the new picture, I have kept the theta. If you think about it, whatever would be the sine theta, that would be same as cosine of 90 degree minus theta. They both are the same ratio. Because I really have not changed much in this picture. Theta is at the same spot and A, B, C, they are still indicating the same side lengths of the triangle. That means the ratio of A divided by C, if A divided by C was the cos theta in the first diagram, then A divided by C is actually the sine of 90 degree minus theta in the second diagram. Similarly, if B divided by C was the sine theta in the first diagram, then cos of 90 degree minus theta is the same ratio in the second diagram, right? So now let's see the tan theta. So now let's see what would be the value of tan 90 degree minus theta. Well, for tan 90 degree minus theta, it would be opposite side divided by adjacent side. So in this case, your opposite side is A and adjacent side would be B. So it is the ratio of A divided by B. And if you look at our original diagram here, A divided by B is actually the ratio of cot theta. It is a ratio that indicates cot theta. So cot theta is A divided by B. So here we can clearly say that this is actually same as cot theta. Right? So tan of 90 degree minus theta is equal to cot theta. Similarly, let's evaluate the other ones. So let's see what would be cosec 90 degree minus theta. Well, cosec 90 degree minus theta would be reciprocal of sine 90 degree minus theta, which would be C divided by A, because sine 90 degree minus theta is A divided by C. So cosec 90 degree minus theta would be just the reciprocal of the sine, that would be C divided by A. And then again, I'm going to refer back to our original picture. What is C divided by A? Well, C divided by A is actually sec theta. You can see right here. So C divided by A, that is actually sec theta. So I'm now going to use that cosec 90 degree minus theta is same as sec theta. So now let's see what would be the value of sec 90 degree minus theta. So sec 90 degree minus theta will be the reciprocal of cos 90 degree minus theta. Now what is the value of cos 90 degree minus theta? It's B divided by C. So sec 90 degree minus theta would be the reciprocal of that. That would be C divided by B. And then let's look at our original picture on the left hand side. So what is the C divided by B? Well, C divided by B is actually cosec theta. If you can see right here, I'm highlighting it. So C divided by B is cosec theta, right? So here we can say, okay, this is actually equal to cosec theta. And then what would be the cot 90 degree minus theta? Let's see. So cot 90 degree minus theta would be the reciprocal of tan 90 degree minus theta, which is A divided by B. In this case, then it will be B divided by A. So cot 90 degree minus theta would be B divided by A. And that will be equal to, if you look at the left hand side, B divided by A is actually tan theta right here. B divided by A is actually tan theta. So B divided by A can be written as tan theta. So it's kind of interesting, right? You see the trigonometric ratios of the complementary angle. So 90 degree minus theta is the complementary angle that we are talking about. So you see that sine 90 degree minus theta is same as cos theta. And then cos 90 degree minus theta is same as sin theta. Tan 90 degree minus theta same as cot theta. Cosec 90 degree minus theta is same as sec theta. Sec 90 degree minus theta is same as cosec theta. And then cot 90 degree minus theta is same as tan theta. So this is pretty interesting. I hope everything made sense so far. Thank you for watching. See you in the next video.